recently I was experimenting to benchmark AI local models. So for this experiment, I took three models. One is Gamma 3, 270 million parameters, and Gwen 3, 0.6 billion parameters, and another Gwen 3 model, which is 1.7 billion parameters. So all these are like local models. So I thought I can benchmark these metrics so that if I am able to benchmark these models in future, any local models can be benchmarked, and that will help me to choose particular model for the project or any use case. So I thought this would be a good experiment to try, and it was fun working on this experiment. And end of the experiment, this became a kind of a go-to tool for me to benchmark local models. So starting with the V0, I just smoke tested these models just to see what metrics I can get so that I can use to evaluate which one is faster and better in performance in terms of response quality. So I just smoke tested in V0, and then in V1, I thought I can wrap everything within a fast API so that later I can bring a front end also to measure and visualize the metrics. So I used a UV package manager and used a Pydantic for schema validation and structuring the output. So introduced two APIs, two API endpoint. One is models and generate. So models will return all the available models on your local system, and generate will help you to get the response of the local model, and it will show the metrics like whatever we got initially in the smoke test. I'm just attaching that to the response. So this was the initial setup on Fast API with Olama client. And in V2, that there is an interesting part where I was able to collect all the metrics and I recorded it. So how I did is I decided to have five prompts, and I'm going to pass these five prompts to all the three models. So it is going to be 15 LLM calls. So for each prompt, I will collect all the metrics and I will compare and see which one is better in terms of performance and which is faster. So these are the metrics. So you can see for this Gamma 3 270 million parameters, and for this model, the time taken to generate the output tokens was really fast. So and the token speed also, you can see per second it is generating like 84, 75, 83. So it is around to 80 to 100, 110. In that range, it is generating the tokens per second. But the problem is the output token count is low, and the response quality also, like compared to these models, it is little low. And when it comes to Gwen 3 0.6 billion parameters, this took a little more time compared to 270 million parameter. And output tokens, in this case, it has generated a good fair amount of tokens, and the token per second is slightly reduced compared to Gamma 3. So this the kind of fair, like a middle ground player in these three. I came to this conclusion after measuring 1.7 billion parameter. So if you see 1.7 billion parameters, it has taken more time to complete. I mean, the generation, it took more time, and the output token is also large. But the time is the problem here. But the quality of the response compared to other two model is good. We can't compare these models with frontier models like GPT or Claude, but for now, when comparing these three models, this is fairly a best model for with a good response quality. So I just noted the observation here. So I just came to a conclusion comparing these metrics, like Gamma 3 is faster, but we can't go with the quality, or like quality wise it is little low. And 0.6 billion parameter Gwen 3, which is a fair player, like it has balanced both the generation time and the quality on a equal way. And 1.7, obviously it is slowest one comparing all three, but produced a good amount of token, and it has generated good quality of response. You can, like when you see the response, you can get to know that yeah, this has been generated, the quality of the response is good, like that. So I came to a conclusion that in this version 2 itself, I can decide which one is faster and which one is better in terms of response quality. But I just want to extend it to another level where I just want a report to be generated. So I collected these metrics first, and then I thought, okay, instead of a manual analysis, like I'm seeing the response and I'm just understanding, okay, this has been generated fast and this is better in terms of response. I thought I can bring in a frontier model. I used GPT-4o-mini for this as a judge, and I would just want to generate a quality score for these responses, and based on that I'll generate a report so that it will be easy for me in future as well. With whatever model I try, I can use any sort of frontier model as a judge and I can generate a report. And I just don't want to look into these metrics in future. I just read the report and I'll come to a conclusion, okay, this model is better comparing all the models. So for that I decided to go with the GPT-4o mini. And in the code you can see, so this is the code. uh, I have a prompt here for GPT-4o mini. You are a strict but fair evaluator. You have to score between 1 to 5 for correctness, clarity, and instruction following. So for these three items, it will generate the score and it will return the response in the form of JSON. So what I'm doing is I'm passing the prompt and answer of each response. So if we have 5 prompts here, so for each model, whatever response I got, I'm just passing it to this evaluator and I'm collecting scores of all the responses. So basically for 15 responses, I'm collecting 15 scores individually, and I'm storing it the JSON format. So this is the benchmark JSON file I got end of the evaluation. So I have a good okay, this is not the benchmark. This is the metrics I have collected before evaluation, and quality score. This is the JSON what I generated after evaluating using GPT-4o mini. So it has given, like, let's say this is a prompt and this is a response. This is a model I have used for that, and you can see these scores. It has given correctness as 3, clarity 4, instruction following as 5, and overall quality score has been, it is 4. So based on this, I'll again calculate the total quality and I'll come to a conclusion which one is better. So in version 5, what I did is I just created a static markdown, which is like, creating a table, and it will have these parameters like average duration it has taken, token per second, output token, and the quality score based on the judgmental by the GPT-4o mini. So whatever score I got from the GPT-4, I just took it and I have averaged it and I'm showing here. So now, and I just came to a conclusion, whichever model has been, like, in the fair, like 0.6 billion is having good amount of time. Like it's not very fast, but it is okay. And then the quality of the response is also good. So I think this is a good one to pick for any use case at the moment, comparing these three. And highest quality is 1.7 billion parameter, which has quality score of 5. And if we come, like, if you want the fastest model, then I can go with the Gamma 3, the 270 million parameter, but I have to sacrifice on the quality score. So this is a conclusion I came with the static report. And so this is actually version 5. Like at this point everything is done, but I thought I can extend a little more. Like I thought I will use GPT-4o mini again to generate this report so that I'll get a detailed report. Like right now it is not that detailed. I have just shown the metrics and I have given my observation. But if I tried to use GPT-4o mini again and generated this observation, like it has similar observation what I had before, but in terms of um, reasoning and polishing, it has represented in a very polished way. So that is a very good thing about this report. So I thought I can keep this one. And finally, at a final observation based on this report, I just came to a conclusion that 0.6 billion parameter is the highest token per second, and 270 million parameter is the lowest average response duration. So in terms of speed, we can say Gamma 3 is the winner, and 1.7 billion parameter is a higher quality in response, but in terms of duration, it is lacking. So this is the observation I got on comparing these three models. Since my system configuration is very small, like 8 GB RAM and 256 GB SSD, I can't test like a local model which has more parameters. So it is not sufficient for this configuration. So I stopped here. But this API tool, whatever I have built, that is really helpful. In future, I can just you know open this benchmark config, and I can update whatever model I want to compare, and I can update these prompts as well with any challenging or complex prompts that help me to benchmark these models. And I can also, in the evaluator part, I can change the judgment model, and I can evaluate the scores, and based on that I can decide which model I can choose for a particular use case or project anything. So it was fun trying this one. This is actually good. So I want to try a lot of experiments like this, and I just thought this is very interesting, and I will walk you through the project. And that's it for now. And I'm working on other experiments as well, so I'll soon post videos on those experiments. So until then, see you. And before ending up the video, if you want to know more detailed document on this, you can visit my website. I'll share the link in the description, and also the repository link. And here you can see the architecture as well. It might seem like a very complex one, but it is not very complex. I have just mapped whatever frameworks and models I have used. So you can see for evaluation part, I'm using GPT-4o-mini here. I'm using light LLM for calling GPT-4o-mini, and user layer is of course a browser or a developer. And this is the API front where we have these API endpoints. We have discussed all these endpoints. And from Olama side, we have Olama API, and behind that we have all the three models where you will be, uh, passing the prompts and getting the responses. And in between, it is for generated files, whatever during the API endpoint execution, these files are generated. So that is what I have mentioned here. It is simple architecture, but in the diagram wise, it seems like complex, but it is not that complex. So that's it for today, and see you on another experiment in upcoming videos. Bye.